Hi, we're Team 19. I'm Zach. I'm working with Jess and Cindy. This is our Quest 6.
And looking at the server, it has three major functionalities. The first one being creating the UDP socket to communicate with the ESP, and the second one being hosting the web client and being able to handle post requests, since we're using post requests to communicate between the web client and the server. In addition to that, we are doing webcam and QR decoding on the browser level, and we're using JSQR to do the QR decoding. And lastly, we have to put the all current split times into the database, and we're using LevelDB to do that. And on the crawler side, we have four major components. The first one being the UDP socket, which sends and receives messages to the server. And we also have a timer interrupt, and it mainly manages two things. The first one is the total time, which are used to record down the split time, and the alphanumeric display is mounted on top of the crawler that displays the most current split time recorded, and IR receiver, which manages receiving IR signal from the beacon. And on the speed control side, we also have the PID part, which is connected to the timer interrupt. So we're using PID in both manual and auto mode. And the wheel speed function basically is the one that gets the wheel speed count using the photoresistor mounted on the back wheel of our crawler. And for the steering part, for the manual mode, it's really easy where it will just react to the button clicks on the web client. And if it's left or right, it will add or subtract 15 degrees from the current steering angle. And in auto mode, we're using the front rangefinder to manage turns so that it turns at roughly 2.5 meters away from the front obstacles. And also, we're using the side rangefinder to keep it straight so that it goes in a straight line along the wall.
Our challenges for this quest were reading the QR code from the Raspberry Pi, making sure the timing for turns was right so that it wouldn't crash into the perpendicular wall or go in circles, and making sure all of the many working parts work together.
When the beacon turns green, the crawler starts up. We're including this clip because we were able to complete a full run in our demo except for the last turn, and we wanted to show that after making some fixes, we can make both turns successfully. We only used one beacon in this clip because that is all we had. Here we demonstrate the crawler operating with autonomous wireless driving. Here we demonstrate that the crawler can work by controlling it with the web page. It can be started, stopped, slowed down, sped up, or change direction forward and back.